Today we're going to learn about solving radical equations. By the end of this video, you should be able to solve radical equations and check your answers. First, a little bit of review. If we have the square root of x squared, squaring that undoes the square root and we are just left with x. The cube root of a cubed is just a. The 10th root of y to the 10th power is just y. So in general, if we have an nth root of something and raise it to the nth power, we're just left with whatever is inside the radical. So when we are solving radical equations, the first thing we have to do is isolate the radical. And then we get rid of the radicals by raising both sides to the nth power. And whatever the index is tells us what power we need to raise both sides to. Then we just finish solving. So in this first example, we have negative square root of x minus 5 equals negative 6. So we need to isolate the radical first. So I'm going to add 5 to both sides. Then I'm going to divide both sides by negative 1. Then, since we have a square root, I'm going to square both sides, and I end up with x equals 1. Now, it's very important that you check your answers here. We can do it just like we've done with other types of equations. We can use the store button, so I can do 1, store for x, then type in my original equation, and it should equal negative 6. So 1 is the correct answer. On the second example here, first I need to isolate the radical, so I need to add 5 to both sides. Then, to get rid of the radical, this is a cube root, so I need to cube both sides. So on the left side of the equation, I'm just left with 8x plus 3, and on the right side, 3 cubed is 27. Then I just finish solving like normal. I subtract 3 from both sides and divide both sides by 8. And I can check and see if that answer works. So I have cube root. Cube root is math and then option 4. And I end up with negative 2, so 3 is the correct answer. If I look at this equation, square root of x equals negative 1, and I square both sides, I end up with x equals 1. But if I plug that back in, the square root of 1 is 1, not negative 1. So when you check your solution, it doesn't work. This is called an extraneous solution. You should remember this word from earlier in the year. Another way to spot extraneous solutions is you think about range of a square root graph. the square root graph just look like this. And you are asked in this equation to see where the square root of x equals -1. Well, -1 is down here. The square root graph never reaches -1, so it is impossible to end up with a negative answer to a square root problem. So that can help you spot extraneous solutions faster. So let's try a couple problems. We have the cube root of x plus 2 plus 5 equals 3. So first we need to isolate the radical, so I need to subtract 5 from both sides. Then, because we have a cube root, I need to cube both sides. So I end up with x plus 2 equals -8. So I end up with x plus 2 equals -8. Then I subtract 2 from both sides and end up with x equals -10. So if I plug this in the calculator, store -10 for x, cube root of x plus 2 plus 5 gives me 3. So this works. Now, number 4 is a little trickier. If we look carefully, the radical is already isolated. So now we're just ready to go ahead and square both sides. On the right side of the equation, I have x plus 5 squared. So that means I have to do x plus 5 times x plus 5. So I'm going to end up with a quadratic here. To solve a quadratic, you need to set it equal to 0, and then either factor, use quadratic formula, or complete the square. So to set this equal to 0, I need to subtract 3x from both sides and subtract 13 from both sides. Then, to factor, I need to find two numbers that multiply to 12 and add up to 7, which are 3 and 4. So my factors are x plus 3 and x plus 4. When I solve this, I end up with x equals -3 and x equals -4. So I need to check both of these answers. Let me check -3 first. So if I have square root of 3x plus 13, that gives me 2, and then if I plug -3 in on the other side, which is just x plus 5, that also gives me 2. So -3 works. If I check -4, square root of 3x plus 13 gives me 1, and x plus 5 gives me 1 as well. So both of these answers work. If you have equations with radicals on both sides, these are actually easier problems. You need to get one radical on each side of the equation and then raise both sides to the appropriate power. So for this first problem, we already have one radical on each side of the equation, and they are fourth roots, so we need to raise both sides to the fourth power. So on the left side of the equation, we just have x plus 14. On the right side of the equation, you need to make sure that you do 2 to the fourth power which is 16, and then fourth root of x to the fourth power. Then you solve like normal. So I'm going to subtract x from both sides, and then divide both sides by 15. Once again, you should check your answers. So even though we have a fraction as an answer, we can still use the store button. And then to type in the fourth root, you go to math and then number 5. So we end up with that decimal, and then for the right side of the equation, 2 times fourth root of x. That gives us the same decimal. So 14 over 15 is the correct answer. For number 6, we need to move one of the radicals to the other side of the equation. So I'm going to add square root of 5x to both sides. Then I can go ahead and square both sides. Since there's nothing outside the radical, I don't have to worry about remembering to square another term. Then I'm going to subtract 7x from both sides and divide by -2. And I'm going to check my answer again. Store 4 for x. Square root of 7x minus 8 minus square root of 5x. And that does equal 0. So this question here asks you to describe when a radical equation will have no solution and why. Well, if you think back to when we looked at our function families, a cube root function has a domain and a range of all real numbers. A square root function does not. And if you look at fourth root and fifth root equations as well, you'll see that even index radicals are the ones that do not have a domain and range of all real numbers. So you only have no solution when you have an even index and if you have isolated the radical and it equals a negative, then the equation will have no solution. One more thing to look at. Sometimes you might see an equation that is written with rational exponents. A few days ago, we learned how to convert rational exponents to radicals. So we're just going to do the same thing here and then solve like a radical equation. So to solve an equation with rational exponents, we need to convert it to a radical equation. So if you remember, the denominator of the rational exponent becomes the index of the radical. So this first equation here can be rewritten as the square root of 3x plus 4 plus 3 equals 0. And then we solve it just like we've been doing. So I'm going to subtract 3 from both sides. If we think about what we just wrote on the previous slide, we said if there's a radical with an even degree that equals a negative number after the radical has been isolated, then there is no solution. So here we have square root of 3x plus 4 equals negative 3. Remember that the index on this, there is an invisible 2 here. So this is an even index, and it equals a negative number. So we can stop here and say there is no solution. If you kept solving, you'd get an answer for x, but when you plug it back in, it does not work. Let's take a look at the next problem. We have 3x to the 1/3 power equals 24. Now, the x is the only thing raised to the 1/3 power, so the x should be the only thing inside the radical. And since it's the 1/3 power, it is a cube root. So I need to isolate the radical by dividing by 3. Then since this is a cube root, I need to cube both sides. So I end up with x equals 512. And again, we should double check our answers. So if I plug 512 in for x, I have 3x to the 1/3 power, and that equals 24. So 512 is the correct answer.